Hello there. Let's get going. We seem to have some pretty good results. I share what you were able to do and get below the 5.35 or something.
Yeah, hang on a sec. I'll share my screen. Can you see my screen?
Yep.
Yeah, basically, I'm not sure I can find it. Basically, one of the I sort of took one of the notebooks that was here. If I can find the right one. Yeah, this one here, LGB baseline train. Yeah, so the notebook that has got me the highest score, it's just like a single model at the minute. Like a lot of those other notebooks, they're like ensembles of a few things. This one here, yeah, so it's basically the guy, like he adds, so he takes it's a pretty simple notebook. So like he just like takes the standard training data and then yeah, like does like a lot of feature engineering on it.
Oh, okay.
Yeah, so it's mostly just like these features being added in that help give the boost.
Yeah, I've seen many people do this
Yeah, like
two combinations.
yeah, because like actually the way I found this notebook was because of the fact if you look at yeah, like if you look at the notebooks with the top scores, these are like all ensembles.
Right.
So like I
Right.
at the start of the week I tried taking a couple of these, like maybe these top three actually, um, and they all failed when I tried to run them. The reason they failed is because of the
Yeah,
fact
in
that
fact,
yeah, I was going to
yeah,
say
go ahead.
the reason they failed is because of the fact that they all incorporate this notebook here, and like this guy, he's like you can see he's up to like version 14 now. And he's been constantly like adding more and more features in here, and like because of the fact he added features in, and those like ensemble notebooks were using the original models from fewer features, then they all failed. So yeah, so I just went and took his and like added these features in. Um, yeah, so like he just like sort of makes four folds and then in the inference just puts them back. The way I got the boost though was um I added an extra feature, do you know, like in the data when you're running it. Um, yeah, so like here's like the line of the API. So you get like the test data. So then he adds the extra features onto the test data, but you also get the reveal targets. So I've
Right.
incorporated the reveal targets in with the training and the test data. And so like that's what took me higher than this.
But when you say incorporated, what does that mean? Like
Um yeah, so
you, how
the
you?
the reveal targets, it gives you the target values from the previous time ID. So
Correct.
what is that,
Correct.
the previous day or whatever. Um yeah, so I took the training, so like with the training data, yeah, like the standard training data here. Yeah, so I just took that and shifted back the targets by a one time step to give me reveal targets for training data.
Like
And
a
then
lag, Steve?
Ah,
yeah, well sort of, yeah. So yeah, just push them back one time
Okay,
step.
okay. So you use like yesterday's data when you're trying to predict today's
Yeah,
data, that
that's
sort
right.
of
Yeah,
stuff,
yeah.
right? Okay, okay.
Yeah, so it's like yesterday's targets, but like the targets are for each of the buckets, the seconds and buckets or whatever.
Okay, okay.
The only problem I had in
so
pushing
you
them,
push.
yeah,
Sorry, quick question. When you say push back, you mean like the reveal targets you push back, or you um, the,
um,
the original the training data? If I can still. In fact, I was trying to understand what the reveal targets actually.
Where's the data?
They reveal the actual values for the next time step. Is that correct?
Yeah, so I don't know how I can see the.
I think the train shouldn't it be there in the train.csv?
Oh, there it is. Yeah, I didn't see that.
Yeah.
Yeah. So in the train.csv, so for example here, where is it? I thought you should have had the target value for like this. Yeah, so you've got like, I don't know, can you see all the columns here? No, you can't.
Yeah, only 10 on 17, so I think you have to just flip that on top there.
Do what?
It says only 10 of
here.
17 columns. Yeah.
Yeah.
All right.
There.
All right. Yeah. Yeah. So you've got like the target, and you've got, yeah. So it's whatever the date ID and the seconds in bucket. Yeah. So if you like,
Right.
Yeah. So here, this target, this one here is for seconds in bucket equals to 0 and time equals to 0. So this one here would have been, yeah, so I pushed that forward, sorry. So this here goes to the next day's one. So this will go to date ID equals 1 and seconds in bucket equals 1. So everything pushes, yeah, so there's 55 seconds in bucket per day. So push all these forward by 55 rows and they end up on the next. Yeah, so they would end up on date ID 1 or whatever it is. So, yep.
Okay. So you push each set of 55 one forward from the, now you do that to the train, or you do that to train, right? So that you have lost the 0th, but you have advanced the train by one day, correct?
Exactly, yeah. So sorry, I don't push them forward 55.
Okay.
There's 55 buckets per stock ID, and there's 200 stock IDs. So I push them forward 200 times 55.
Right.
So as they end up on the same stock ID, but for the next day. So for
right.
any given day,
yes.
it's the previous day's target. Yeah, and then like within the test, yeah, so like within the test, you get the test set, and yeah, so like in the example test files, yeah, so you get the test and you get the revealed targets. So you can see here in the revealed targets, it's got the date ID that it's coming, that it applies to, but it's also got the revealed date ID. So yeah, so this target here, as you can see, it's coming at step 478, but this was the target value from the previous time step at 477.
Steve, how similar is this to the crypto one? I was curious to know. Do you see similarities in models?
Similar to what, sorry?
There was a cryptocurrency one that you guys did, right?
Yeah, so yes, so that competition, this is practically identical.
Okay.
Yeah, so wherever it's gone. Yeah, the Ubiquant, however you say it.
Okay.
Yeah, so within this competition, they gave you 300 features, and like similarly, like yeah, it was like an investment ID instead of a stock ID, and the time ID. Yeah, so here it was like 300 like anonymous features.
Okay.
Yeah, so like once you start taking the training data from this competition and start doing the feature enhancement stuff, so so I'm up to about 150 features now, and like then everything else is practically identical. So like all the models and procedures and stuff I used before, I should be able to reuse them.
Okay.
But yeah, so like I got like a pretty good submission, and then I thought, well, I'll sort of, rather than just use, so it's just like an LGBM thing.
Right.
So I thought like I'll take that and I'll, like Optuna where you can tune it, where you can get like tune all its buckets and whatever they are. So like I stuck it through that and I got like a brilliant cross validation score, and yeah, I thought I was gonna be top of the leaderboard and submitted it, and it's like I had the worst score I've ever had. It was like worse than but yeah, so far none of my cross validation matches with what the public leaderboard's shown me.
Oh, I see. Okay. And this is like a time series cross validation taken into account, I'm assuming, right?
Well, I just took the training data and split it into 5. And I only used like the first 4 blocks for the
Consecutive.
training
Okay.
data, and the 5th one for the validation. So yeah, the 5th one was after the first 4.
Okay.
And yeah, like it gave me a really good score, but once I submitted it, it wasn't so good. So yeah, I think I need to find a better cross validation method.
But actually, I found, to your point, Steve, of using the cross validation, the one thing which I just used a couple of different notebooks to submit, and they use some of the PCA analysis, which I haven't dived into how that helps, because that seems to be somewhat different approach beyond the feature engineering that you shared, right? Like the combination of the various prices, the 2 combinations, and then the 3 combinations, which you showed the LGB baseline guy using, and then there's like a PCA stuff that some people are doing. But in all of these, the one thing that I was surprised by is what Raquel was asking, that none of them seem to be using the time series split, which I thought was kind of pretty critical when we did the prior time series competitions. That one of the key things, at least that I recall from learning what these various time series methodologies that we were trying to use, one of the critical things was the split should be such that it never uses prior time data in the validation and what you'll see. And that can only be guaranteed by using time split. But for some reason, none of the notebooks that I've seen, I haven't looked at the LGB baseline train one that you pointed to, but every other one that I saw was using simple K-fold, some SK-fold, stratified K-fold, but most of them then reverted to just using K-fold. And I was surprised that, and in the comments to one of the notebooks, somebody had asked, hey, how come you aren't using timefold? And the guy said, well, I plan to do that. And I was surprised that simple K-fold that they were using was still yielding the results. I haven't kind of kept using the timefold or the time series split or whatever that appropriate thing is called.
Yeah, so yeah, like because I was just like sort of making up baseline results or whatever. As I say, I just used the first bit of it as training, and like the last bit as validation, just as a simple sort of test. But yeah, like now I've got a more advanced like group K-fold where it groups it by time. But yeah, like I remember in the last competition, a lot of people used this thing, this combinatorial purge group K-fold, which comes from this book, Advances in Financial Machine Learning. And like it was the one we looked at before, which had like there's like pictures of, I'm not sure will this show it or whatever, but like there's pictures of which bits it which bits it takes and stuff to like try and avoid yeah, like trying to avoid leakage from the previous time bits. But yeah, I haven't got on to yeah, like this one here is the one we saw before in that previous competition where it's yeah, like it takes like little bits or whatever, and it's using these as the validation as it goes through and stuff to avoid the leakage. Yeah, so
Yeah.
this approach here would probably give you a better cross validation. Yeah, for time series, whereas yeah, like I haven't seen anybody else yeah, sort of trying that hard to stop their leakage yet.
Yeah, everybody is just using K-fold, and I was like, man, that seems like a very first thing that, at least in the prior competitions, was highlighted as a very critical thing. I didn't remember this combinatorial for K-fold, but definitely remember that you can't just use K-fold for time series data, because when you're doing that, then when you split into folds, then using one fold, you're just shifting it around, and you cannot shift and use one fold when future time points are used as data, and you're using a past and stamps as validation, and that simply can't work, or shouldn't. I mean, that will give you bad TV. So I was surprised that people were still doing K-fold, and that's how they trained all these various models that were then being used, but somehow was still yielding reasonable results, or at least for the leaderboard. And I was like, wow, that doesn't seem very good for, hopefully the private leaderboard or whatever. And yeah, I was wondering whether anybody at all in the, I didn't have time to check, but whether anybody had kind of used timefold.
Yeah, no, I haven't seen it, but yeah, like obviously the people at the top could be using that who haven't made any public notebooks. And like in terms of sort of evaluating how your model is going to perform in the testing period, at the end of the competition, yeah, you have no idea really if you're just using K-fold.
Yeah, that was my concern. It's interesting. Yeah, I'll definitely look at this combinatorial purged K-fold. I forgotten about that, but yeah, spent quite some time in the prior competition kind of focusing on, hey, what does it do and why it's better, and that was one of the key things that stuck in my brain. So I was like, wow, I thought that was kind of first thing. But the other thing is, I haven't seen anybody use any kind of deep learning methods at all. Have you?
Um,
I haven't looked very hard, but
in the previous competition, there's a guy called Lonnie, I think his name is, or something, and he'd like done like a neural network thing which I'd used in the previous one, and he has like a notebook in this. So I tried that, and it didn't give me that good a score, and like I tried the neural network approach that I'd had previously, but again, it didn't give me as good as the LGBM thing.
LGBM.
And I was looking back
And
at
did you?
I was looking back at the winning solution from the Ubiquant one, and the person that won it, they just used 5 LGBMs plus 5 tab nets, and that was it. They didn't use any neural networks.
When did the Ubiquant run, by the way? Do you recall off the top of your head? Or,
It was 2 years ago.
Okay.
Steve, any
I was
sorry, I was just going to ask
Great.
XGBoost versus LGM. Do you have any intuition why one over the other or anything in that direction?
None at all. Yeah,
Okay.
I don't really know what I'm doing. I just like take people's notebooks who have got LGBMs and take their parameters or whatever, and they seem to be
Cool.
good. As I
Okay.
say, I stuck it through the Optuna thing to like tune all of my
Uh-huh.
leads,
Uh-huh.
depth, whatever. And as I say, like in the cross validation, it gave me brilliant results. And then when I actually stuck it into the competition, it was rubbish. So
Okay.
I'm not sure why that is, but
This guy is a Kaggle grandmaster, Rob Muller, and he seems to be like time series and that kind of a domain specialist. So I just posted a bunch of videos. I mean, if you look at that YouTube channel, you should be able to probably follow along. He talks about lags and XGBoost and yeah, a bunch of those things. So I was following that. It was a pretty decent resource.
where did you publish them? Sorry.
Oh, sorry, just right in the chat. And I think he is taking part in the competition too.
Yeah, see it now. Sorry.
Okay.
Yep.
And I don't know if you guys did you guys ever get hold of the Kaggle book, the Kaggle workbook or the Kaggle book? I don't know what I can't remember what it's exactly called. It was like with no?
No, I haven't heard
Okay.
of it.
Yeah, I've heard about it, but I haven't downloaded or I haven't
Okay.
purchased or.
So the same author has
gone through it.
okay, the same author, Luca Masseron, has a book with specifically for tabular data, and it's still in the process of writing. But he's got chapter 5 and 6, which is yeah, I've been kind of going through that, and yeah, kind of what Steve showed with the LGBM stuff, the lags, all that stuff is kind of making sense now. This is my first tabular data stuff, really. So it's very interesting. Like, yeah, those are I found those two resources. One, I think the book obviously is paid. It's like $30, I think, but the Rob Muller videos are free on YouTube. So yeah, just wanted to share that.
Yeah, the last competition,
Great.
Jeremy Howard's Fast AI book, he's got like a chapter about
Yeah,
boost and stuff. Yeah, I thought it was pretty good. So the last time I went through that, just get a bit of an understanding for them.
Yeah.
Yeah, actually, I remember the LG. I don't know about the L part, but the GBM part, Reckle, we went through and in
Right.
the machine learning with scikit-learn thing, if you recall. And in fact,
Right.
we had gone
Yes,
to
yes.
explain how, you know, the
Starts out
where
with
it starts
the average.
from and
Right, right.
yeah, the average, exactly. So that's the part I
Yeah.
recall about at least gradient boosting machines. But
Yeah, okay.
again, there seem to be like 3 or 4 variants that I don't quite, you know, there's one among the common top notebooks that Steve was pointing to. They all use like 3 or 4 variants. And I was also curious to put in my brain, what's the difference between when there's like a, you know, CB, there's, you know, just the basic
Cat boost. Oh, okay.
Yeah, cat boost, and then there is a HGBR, which is histogram based gradient boosting. And
okay.
then there's the light gradient boosting, and then there is a XGBR. So I kind of wanted to, you know, kind of just, I remember very vaguely the difference between cat boost and XCB, but I don't, if you ask me to explain that right now, I couldn't. So I would just wanted to kind of maybe create a table for myself so I can go back and refer to it some other time. Oh, okay, what are these 4 things and how are they different? XGBR, the, you know, histogram based GBR, cat boost, and then the LGBR.
Yeah, I haven't even heard of the histogram post one. Light GBM, XGBoost, are the 2 ones that, yeah, I'm kind of at least have heard and like are familiar with, but the others, yeah.
Then since we just kind of, let me share, I created this few links. These links, can you see my screen?
Yeah.
Yep.
So these are some more recent things that showed up. So just there's something called Time GPT that apparently showed up just this year, and it's one of these foundational models for time series forecasting.
Okay.
And we train on 100 billion things, so it's almost like they expect it to work much like the foundational LLMs do, with no pre-training. From what little I saw, I haven't yet gotten into the details of it, but just saw this. And you know, the guys have a GitHub page for it.
Interesting.
Like Time GPT.
Okay. Transformer. Interesting. Okay. I mean, the recurring theme in the book where I was reading was basically stick to XGBoost or LightGPM and create your features. The deep learning approach still hasn't really worked its way up to like the top of the leaderboards for the tabular stuff. And your main thing was like data is not really available like in images and all that to kind of transfer learning, use that kind of concept. So that was the main reason they were talking about. But yeah.
Yeah. Now, when do you know when that book was published?
I mean, it's still being written. So like chapters keep coming out.
Okay. So it is current.
Yes, it is current.
Okay, so it is current.
Yeah. Like
That's interesting because
sorry, I was just saying like I think there are like 10 or 12 chapters, and like he touches on deep learning like only on chapter 9, where they talk about the fast AI approach, and then like TabNet and the other things. I think Steve also was sharing like from Ubiquint or one of those competitions. I'm guessing it'll be good for ensembling. May probably help in that sort of a scenario, but I don't know if it's solo. I mean, if it's a solo model, how?
Yeah, in the last competition, yeah, like I had like about 5 or 6 different things. So like TabNet was one of them, and yeah, like one-dimensional CNNs. But yeah, the people who won it just had LGBMs.
Okay, I see. And was that like a what is that called? Ensemble of LGBM? I mean, LGBMs or?
Yeah, so they had 5. So I think they were just, yeah, like what I did in the last competition was just like trained 5 LGBMs on the full set of data, but with different seeds.
Oh,
so you get
okay.
slight variety in them, yeah.
Nice. Okay, I see. Okay, cool. Do you have your old competition notebook public? I'm just curious. I would like to actually start from there, know something that works, and then.
It's not public. It includes in about 20 notebooks or whatever. So I'm not sure what it's still run. And the other thing is actually you can't actually get the training data. They've taken it down from that competition.
I see. Oh, interesting.
That's what tends to happen quite a bit in these financial ones. As soon as the competition's over, the company that's run the competition gets rid of the financial data. So yeah, the old code wouldn't run anymore.
Oh, okay.
But yeah, if you just look at the competition, and if you look at the winning solutions, the top sort of 5 or 6 have all got explanations of what they did. So their code's probably tidier than anything I wrote. Mine was just bits and pieces sort of stolen along the way. So
okay. Yeah, we'll check that out. Yeah. I think for me that's where my starting point should be. Trying to jump in here is it?
Yeah, no, as I say, I don't think many people have sort of realized that competition is so similar to this one. So
okay.
Yeah. So.
Cool.
And to your point, Rachel, the other interesting thing that I recall when we did I don't remember whether it was Ubiquint or the one after that, we did 2 time series competitions. And in one of them, I think there was so much data munging that had to be done that finally, I don't know whether Steve gave up, but at least I recall, I think I gave up because there was so much of just data manipulation.
Oh, I see.
Yeah, that one was a nightmare. It was just I spent all the time moving data about and stuff. So yeah.
Interesting.
Yeah. So I think Steve was a little more persistent than I was. I was like, oh my God, what am I doing? I'm just like having data around constantly and getting nowhere. And I couldn't even get the dang thing to run. But in the process, the reason I brought that up was it was in that competition that digging into some of the references, thanks for pointing those out, that I found out that there is and I think Yuri last time too was able to kind of point out from the top of his head what I'm referring to. But there is like an annual time series competition that takes place. It's like an annual event.
M3 forecasting and the M4 forecasting. Yeah.
Right.
That's the M series. Yeah. Right.
The M series, right? And in that one, the interesting thing that I recall is in the last, and I think this was definitely not this year, but maybe that's why I asked you which year was this a big one, because the M series one, the last time, which I believe was the year before that, that means not in 23, but in 22. So it might have been the 21 one or the 22 one, I forget which, but that was the first time I believe that the top entry and potentially like the third entry or something like that were actually deep neural networks.
Oh, I see.
And, so they were kind of beginning to get themselves to the top of the leaderboard. Of course, if you still looked at the top 10 and chose, maybe they were like, still less in number than just the LDBM oriented techniques, but they were beginning to again make an appearance at the top of the leaderboard or thereabouts. And that's why I was curious whether, some of these, and then I don't know how valid the claim is that this model, TimeGPT, is like a foundational model. I mean, I guess, they're just calling it that, but at the same time, if it's being trained on, I forget what they said in this, it's trained on like some 100 billion series or whatever, then that might be interesting. I was just curious how, reliable it is. And then if you can see my screen still, these four seems to be like the hit parade recently of what's most recent types of models, because none of these, I've just kind of identified this over the last couple of days, and at a minimum, I wanted to take a look at them and see whether any of these could be used simply because I believe this NBeats was what I was trying to use, and I got horribly lost last time. I think we even looked at the paper or something. But the name rings a bell. This was NBeats. And then there is this NHITS, PAT, TST, and TimesNet. And these apparently are the kind of the more recent innovations. FYI, I'll post a link to this particular write-up so that, people can then take off from there and look at any of the other ones.
So is TimeGPT now available for general use?
Yeah, I believe so, Yuri, because this is they say getting started, quick start, tutorials, all of that is available. You can just say from NX, whatever, NXT, LATS, import TimeGPT.
I guess you can get token from them.
I just bookmarked this like yesterday or day before, so I haven't looked at
whether... The reason I'm asking, I looked at that model a few months ago, but at that time it wasn't available. So I requested access, but I haven't heard back from them.
Oh, interesting. So you couldn't,
maybe
you're saying
maybe use it? No, but at that time they really were looking for experts to use it first. But now I guess it's available.
Are you going to be able to use that as well in this competition though, if you've got to have internet turned off?
That's a
Will it be
good
possible to
question.
create like a
Do
private
these
data set or
reels
something?
thingy or whatever?
Yeah. I don't know how easy it is
That's a
with
good question.
one of these things.
Guessing that would be a pretty huge model to bring in.
Yeah.
Yeah.
Yeah, like
So
I know in the last competition when people were trying to bring in the whatever
it's 70
that
billion
was.
by the right.
Yeah. Yeah, they had to split it across like 2 data sets or something. So it could be a nightmare to bring that in.
Correct.
I should bookmark that notebook and just use
Yeah.
this out. Right.
Hey, Rakel, nice to see you again.
Hey, Mehul.
I had a general. I was looking at the competition description. I don't know. Yeah, I don't get it. Like, so it's the last. It's the closing of the stock market, and okay, so the stock prices are moving a lot when in the last 10 minutes, right? And so what's our objective? What do we want to predict what it will close at?
Well,
Yeah,
you're trying to
for each of the 200 stocks. And
so
in
it's not
effect,
just the closing
I
price
think,
though, is it? It's like at the end of the day they've got how many periods? Is it 55 periods of 10 seconds
Okay.
with target prices. So for each stock you need to predict those 55 for each day.
Mm.
think of it this way, right? You're predicting, see, getting into weeds, I mean, it took me a while to mail, so to get at like what is going on. And the two things that seem to be going on is, in the typical stock market that you're aware of, people are putting in sell orders and buy orders, and then, somebody willing to buy at this price and that price, and they give that name, I forget, something book, right? Like an ongoing book. And then apparently for NASDAQ, in the last 10 minutes, you can, or even throughout the day, you can kind of place an auction book, which means that, oh, I'm willing to buy this number of shares at this price, but execute it at the end of the 10-minute period when they begin to have this auction. And that can obviously cause swings in the price as well. And then there is this combination of what I just said, which is the auction book, and then the original, everybody buying and trading, which continues to the last 10 minutes as well. And then through all this, all of that data is provided to you, and then they just want you to predict over the time period, as Steve was pointing out, how the stock will move for each of the 200 stocks over 55 time steps.
Okay, 55 times. Okay, so okay, so let's say, each stock 55 predictions.
That's right, yeah.
Okay, and most likely those predictions are so that's the fun part. Those predictions are correlated, right? They're because like normal, all our other stuff, interesting. Cool.
Yeah,
so that's why to your correlation, that's why many of the features that Steve was talking about, what people are doing is not only taking individual stocks, but looking at groups of stocks that seem to tend to move in the same directions, and all these kinds of analysis to create features that will help guide any individual stocks and prices, besides the obvious its own price, if you will, through the buy and sell orders in both the auction book and the whatever. I keep forgetting what the name of the ongoing book is, but there is a better name than ongoing book, but whatever that is. So that's how, especially what Steve said about all the features, 150 features that he has now, is through generation of a variety of those kinds of points.
Okay, and those 200 stocks, do they I sorry, I didn't look at it. Do we know the names like it's Nvidia, AMD, whatever?
No, it's
No,
all
no,
anonymous.
they never
Oh,
name
it's
it. I think
anonymous.
just numbers.
Yeah.
Then how people are just grouping it by looking at how they're moving in the training data.
Yeah.
Oh, okay.
Like, in fact, actually, one of the um, books that Steve pointed to, let me see whether I can point you to that, is really, I mean, it's like exceptionally detailed analysis of exactly what he was mentioning. Let me show you the one. Yeah, this notebook, can you see my screen?
Yeah.
Your extensive EDA, it has like incredible analysis of all the different ways. So, for example, just to give you an example, here are 200 stocks, 200 plots of what is he analyzed?
Okay, cool.
He's analyzing, so he's done this analysis and through this notebook of like incredible number of plots of multiple 200 plots of different values. I'm just even trying to get it. Let's see whether I can quickly get. So
Yes,
there are like.
Yeah, I looked at this and yeah, I didn't understand what it was on about. And the competition notebook as well, it explains it well about what the sort of buy and sell things are and like which book is which and whatever.
Okay.
But yeah, I'm just treating it as like a table of a load of numbers and a target. And I don't care what they are really. So,
right.
But yeah, because of the fact that you have the 55 buckets on each day. So as you say, like they should be related. The price, if it's going like down or whatever, it's probably, if you take average price over the buckets and things, then it's probably useful.
Yeah, so here, for example, you might be selecting something and then just aggregating some, and then so he just did some volume weighted average price and then reference price. So then he plots it for all 200. So like that in the notebook, if you look at, I mean, it is just like incredible number of plots. As Steve says, I mean, your eyes glaze over. So what do we do with it is the more important or interesting question than just analyzing every one of them. But exactly to your point, I mean, there is just a ton of, and there's, as Steve also mentioned, you can see in the basic, I'm trying to even some basic thing, the basic submission. This is submission, but there's a basic demo where they go into what the terms are and what they mean. But as Steve said, I think in a prior meeting or whatever, you can, after you've kind of gone through it one time just to get the lay of the land, you can abstract it away and just deal with those as some numbers. But in order to create the features, I think having an understanding of what they are matters.
Yeah. It's how do you scale like, so some stocks, for example, Nvidia is trading at 400 plus now, right? But Intel is trading at 50, right? So what how do you scale the stocks so that because I don't like what's the, like, do you just do divide by the mean and subtract
Well, their target is actually, like they're using that WAP thing.
WAP thing. Okay.
The average. And so like they divide whatever stock it is, they divide its price 6 time steps into the future by the current price. And then they subtract some other weighting thing that they have.
Okay.
So yeah, like that's how they've sort of averaged over the stocks. So yeah, like the fact that like Nvidia or Apple or whatever may have really high price stocks and somebody else might have low stocks doesn't matter because the fact it's just sort of relative to itself, I think.
I see. Interesting.
Yeah, and they also refer it to an index of, I mean, they kind of compare it with reference to their own created index. This is the other reason why Steve was saying earlier, right? Like some of the data is proprietary to the companies that run. For example,
Right.
I'm sure the index they're using is not, a public index, but index that they have created. So that's the other reason why, they blew away a lot of the data once the competition is over.
Okay.
But the fun part of these competitions is they actually take your notebook and then run it over the next 3 months.
Mm-hmm.
Be in the real world,
Yeah.
the real world model to them how your model actually performs.
Okay, no, that's great. I have one more question. When I joined, Rekil was talking about, I think, XGBoost and LightGBM. So, as far as I remember, like the basic XGBoost and LightGBM don't have the temporal component. So how do you add time into XGBoost and LightGBM?
In the notebooks I've seen, yeah, so they add like time features into each row of the data.
Okay.
So yeah, so it's not as if you're sort of putting in several rows into the model, but the row that you do put in contains your like average values from the time steps that have gone before.
Okay.
So yeah, like it's not like a recurrent neural network or whatever we're putting it in.
Okay. Interesting. I see. So you design your features so they capture the time relationships. Nice.
Yeah. Yeah.
Okay.
I think it's like
there
similar
isn't
to
an explicit time component.
like same thing like if you use a random forest, you can make predictions for time series events, right? It's just that each row you kind of incorporate something which kind of says that the previous row is 1, so this is like 2, 3, 4. So there is some connection there, and then you hope that the model kind of picks that up.
I'm really curious, like before all this deep learning bullshit took off, like there's some really cool longitudinal data analysis stuff. That'll be interesting to see. It's I invented a new hobby. I buy textbooks and then I don't read them. I'm getting pretty good at that now.
The key to making that last is somehow hiding that from your significant other. I can tell you from personal experience.
Hide the costs. Yeah, this book is only 100.
Yeah, I'm the same. And then I went to try and sell them like second hand, and because of the fact that technology moves so quickly, they're worth absolutely nothing now.
Yeah, and they have like the 10th edition with a few changes, so nobody buys the 7th or the 6th one that you have.
This is what I get for suggesting a book. But seriously, like on a serious note, like Mehul, I'd probably lead you in that competition because I get it from work, so it's not even my money. So
you get it from work. Oh my god!
I make them continuously buy books. So yeah, but seriously, this one especially, that was the main thing. Like I think it ties. If there is an objective like a competition like this, you're taking part for 2 months, kind of ties in well. So
yeah.
I think like I'll share some stuff next time. I don't know, since it's a paid book, like going over it like on a recorded thing could get us in trouble. But maybe if you're not recording and if you just kind of hang out, we can kind of.
I don't think. No, and especially if you're just discussing it. I mean, it's like discussing Jeremy's classes or something, right? Like
but Jeremy's classes, nothing is paid, right? Everything is free there. The book costs over here. That's the problem.
But what I'm saying is, true. But if you're just sharing some specific pages, I mean, I think, if you're saying, hey, look at this page, he says this here, or this page, I think that shouldn't be, because, there is a law for, there's even a law for appropriate copyright use. So as long as, for example, Google Books even used to have like a limited number of pages.
Right.
And we are not obviously going to be able to discuss, but there are like 20 pages or 40 pages or whatever snippets are allowed to be in the public domain for free as long as you're, not like publishing it. So I don't think from that perspective, like if you're just focusing on particular segments of chapters or things like that would be prevented from doing so. I mean, even, for example, the scikit-learn book, we kind of went through it chapter by chapter and looked at specific.
Right, but we never,
right?
did we ever read through the book? We always read it on our time, right? Like, we never read through the book. That was the main reason.
Read it in public. That's true. But but we can, maybe each get it and then kind of discuss. If you're discussing or even putting up 1 or 2 pages which are specific and discussing that, I don't think that'd be a problem. By the way, on a slightly humorous note, I think I have both you guys beat on my thing when I was actively working, because I was trying to get a group trained from the ground up, and that became the excuse for building a library pretty much. Saying, hey, what do you mean we don't need computer architecture books? I'm training this entire group on computer architecture. So how do you think I can accomplish that? I think we all come up with our techniques to humor our hobbies.
I had one more question. Do you know if I am on, also, so Rekil, the book you mentioned was that Rob Muller, right? I think.
No, sorry. Rob Muller is the guy with the
YouTube. Okay.
YouTube. Let me share the guy.
Because
is it the Kaggle book?
Kaggle book.
What it's called, or is it?
No, that's the different book, but it's the same author here. So he brings in a lot of like actual Kaggle competition stuff. So I think they throughout use an Airbnb data set. Where is it? So yeah.
Okay, cool. And
okay.
Yeah, I was listening to the conclusion you're saying, that for tabular data, using the like decision trees and there was one more paper like that. Do you know? I'm just trying to search for it. If I'm on LinkedIn, right? And I know the person who posted it, but his name is Bohan, who's also one of the Kaggle grandma. Yeah. But
how Boost advocate.
Yeah, he's like actually Bush advocate, but he posted a paper. Is there can I do keyword search on LinkedIn? Like anybody really good at LinkedIn searching? Like I can't find the damn thing.
No, is that the one where they claimed it was better, but then he sat and disproved half of it?
No, it's
I
think it's a really it's a paper, like a very extensive paper comparing and it's like to Srinivas's point, it's like recent work comparing deep neural networks and for different tabular data sets. But okay, I'll try and dig it up.
By the way, one other tidbit that I was using to I have a little bit of time to spare than you guys, so I kind of was using this is Manning publishes a request for reviewers. So in fact, this PyTorch book that Steve has talked about previously, where they kind of went through basics of PyTorch and all that. And I happen to be one of the early reviewers of that. So if you sign up to review books, then they send you those books for free.
Yeah, yeah,
So,
that's one more way.
you can
Nice.
just go through and comment, but you do need to read it and comment. But if it is particular and relevant, then obviously it's a
Right, makes sense.
useful
Yeah.
thing to do anyway.
Right.
If you don't review it, do you have to send it back?
I think they send you an electronic one. So.
All right.
No, they just drop. Yeah. They send you a PDF or a link, and in fact, in that case, they had linked to the notebooks and stuff. And I think, in fact, and if you recall, Steve, the second half of that book was all about how they used it in like a medical imaging type of application. And my problem was, whenever I tried to run that part of it and stuff, it kept running out of memory and stuff. So I was like, guys, what are you doing? Just drop that thing, or else use simpler stuff. And it turned out that they retained that part, but mostly what the book is used for is the first part, which is, all the PyTorch.
Yeah, no, I thought it was a good book, but as you say, like the whole second half was a whole sort of project they did with masses amount of data. That's why I can review that book probably, because like when I'm going through a book, I'd like to sort of run the code and stuff. It would take me 6 months to go through that book.
Yeah, exactly. And that's exactly what happened with me. And I was just like, yeah. So in fact, my review of the second half was, I can't run this. So what do you expect me to say? Like, how do I even know this works? And in fact, the guy was coordinating it, said, "Oh, thanks for that input. That's very valuable input." I was like, okay, whatever. I mean, but thankfully, they didn't drop me from the review.
Steve, to your point of the lag features, that thing that you were talking about, the Rob Mola YouTube videos, he looks at some, energy consumption data, and he adds like a 30-day lag, a 60-day lag, a 90-day lag. And he makes a mention of like your lag shouldn't be more than how further ahead in the future you're looking, because then you don't have data for that. So I'm wondering, like, maybe a couple of days, like if you add one more column and then and so just adding like the previous day, maybe 2 days prior to that, like with a lighter weight, like, does that make sense? Like what I'm saying?
Yeah, so that's actually some of the features I'm adding now.
Oh,
so
okay, cool. Nice, okay.
As I say, I took that notebook I talked about before, which is the sort of the one that's in all the ensembles in this competition. But I went back to a notebook. Yeah, if you look at the winning solution out of that other competition, they talk about, like they use like lag features or time features in that. So, but so I think that's a good idea, like to do that.
Yeah, okay. Cool. Yeah.
One thing I was wondering in this competition, like as Srinivas said, the competition finishes, when is it?
3 months.
Yeah, 20th of December or something, but then it runs for 3 months afterwards. So like obviously you're going to have 3 months extra data coming into your model via the for loop or whatever for each day's prediction. So what would be a good thing would be if you could like train your model as it went along.
Right.
But
incorporating all the new data. Right.
Exactly, yeah. Whereas like all of the stuff at the minute is just training the model on the training data and then using that on the test set. So it's not taking any advantage of the new data that comes.
New data that comes in. Okay.
But I wasn't sure if you're using like LGBM, can it retrain on new data, or will it sort of forget everything it's learned before? Do you have to train on everything you had before? Like I know like neural networks are meant to have catastrophic forgetting or whatever. You can't just get it to sort of, here's like a new example, add this to your collection. I wasn't sure about LGBMs.
That's an interesting question.
You don't need to like train it on every single row of the new test set, but you could like retrain it every 100 or something. So as it's got a chance over the 3 months of keeping up to date.
I'm curious, like, wasn't the Ubiquint one the same thing? Or was that different?
Yeah, no, it was similar. So they gave you like a training set, and then halfway through the competition, they gave an extended block of data, which was the data that had been generated since they launched the competition.
Okay.
Yeah, like I remember me and Srinivas were like trying to get models that sort of trained as they went and like trained as part of the submission. But yeah, it was hard to get them to run.
Yeah, and then I'm guessing we have a 9-hour limit in which you need to finish training and influence. So
That's right, yeah.
right, yeah, that's
And that's the other part, right? Like, in fact, now that you mentioned, I'm vaguely recollecting that one of the ways that I thought we were trying to do that was to junk the
older data.
past, because that
Yeah,
becomes
okay.
less and less, like, shift the window, right?
Right.
And it kind of tees off of what you commented to, Rekil, which is, okay, so if you're doing it, you've trained the data and you're ready to go. Now 1 month of data shows up new, then, would it be better to drop the last month and add the new month?
Right.
And thereby keep it fixed at some number of months, but don't go beyond that number at any given time.
Right.
I thought we had done or tried to do something like that, but I have to go back.
Yeah, we did, but because like I had like an ensemble of about sort of 7 different models, I think five of them I couldn't do it on. So yeah, so I think I retrained a couple of them as it went. But,
okay, cool.
But yeah, like it sort of as says, yeah. So it was a sort of sliding window to try and keep the most recent data in and drop the old stuff.
Yeah, I remember a very similar thing with random forest with Jeremy talking about like, and so just dropping like weighting with random forest. I think which one was that? Like that bulldozer competition that he talks about with his...
that prediction of the prediction of sales, right?
Yeah, the price sale. Yeah, right. They use like a...
Yeah.
Sorry, go ahead.
And I was just going to ask, I guess, so yeah, competition finished, it runs for 3 months, but, sometimes stocks have like a stock split. So, like for example, when NVIDIA had a 4:1 split, so it was 600, and then it basically after the 4:1 split, it's 150.
Okay.
So do they, in the next 3 months, if a stock's in that list splits, or I don't know if they said no, we won't take.
Shouldn't be that hard, right? Like since if it's a split, you should be able to account for that, or right?
Oh, the model should account. Yeah,
I think
okay.
the weighting.
Exactly.
The weighting thing would average it out would be my guess, but
Okay.
I haven't sat down and done the math to make sure that is actually the case. But my guess is because it uses the weighted average and all that it would kind of even out, because fundamentally the split again, because of the numbers increase, right? So when you do the weighting, then everything should work out.
Okay.
Or worse come worse, they would drop that idea. If it still works for 199 of the others, right? You'd still like to keep that.
By the way, the other thing, since you brought that up, Rekil, the other thing I was going to comment on was, in some of these models, and I was going to ask Steve, I haven't seen explicit code that says, kind of, other than dropping some values or something, I haven't seen any steps people take to say, oh, these stocks don't have, and the EDA definitely shows significant number of some shares missing a large number of data points. But other than the dropping of those, I haven't seen any other action taken, right? Because it's pointed out, I think, even in the setup to the competition, that not every stock for every time step for every day will have the data.
Well, it does actually, but it's so in the early dates, there's some stocks missing. So if you look at the early dates, there's maybe only like 190 stocks. Whereas like by like the end of the training data, all 200 stocks are present. Yeah, so like that's the problem I had. But when a stock is present, all of its 55 bucket times will be there. So like when a stock is present, its data is complete. But yeah, so that's the thing. Some stocks may come in or disappear from the training data, because that's the problem I had adding the revealed targets in, because you can't just shift by 200 times 55 because of the fact some stocks are missing in the early ones, and so
yeah.
I had to put like dummy entries into the data frame to fill in stocks that were missing in the early time periods to fill those in and then pull them back out again.
So you look on ID and then fill?
Sorry, what was that?
So do you look at the IDs and then fill it in? I'm just curious, like that's an interesting point that you bring up. If things are missing, you can't do something like a general shift, right?
Yeah, so you can make like a dummy data frame where, yeah, you take the 200 stock IDs and you just make a basic dummy data frame from 200 data frames times 55 times the number of dates. And like that gives you the dummy thing. So like it's a complete data frame, and then you merge that with the existing one, which fills in the blanks. So like
okay, so that's what. So the merges on the stock IDs?
Yeah. Well, the stock IDs
okay.
and the time IDs, yeah.
And the time IDs, yeah. Okay.
Yeah, so that fills it in. You get like dummy rows, which
I see.
is then complete, and then you can shift, and then get rid of the dummy rows again. Yeah.
A lot of subtle manipulations.
So you need to do that only if you're using the revealed data. Is what you're saying,
that's right. Yeah.
But what if the revealed data is missing stuff?
You'd still be using it, merging it, right?
Yeah.
No, so if you're still merging it, you'll still have a dummy. So you're basically predicting with a dummy value.
Yeah, that's right. Yeah. So for the stocks that don't have any entries in the first couple of time periods, yeah, like they just have revealed targets of 0 for their first entry.
And if there is missing data in the future as you move?
Well, it doesn't matter, I don't think, because of the fact that you're just merging in.
Merger's taking care of it, yeah.
Yeah. And they've said that during the competition they'll not introduce any new stocks. So some of the 200 stocks may disappear, but they'll not put new ones in that you haven't trained on.
Okay. Cool. So so excited to try what you've suggested, Stephen. Let's see how far I get in the way. That is very cool. Oh, by the way, the simple thing that I found on this book was like talking about missing variables. I mean, it seemed pretty obvious after I read it. It was like, why don't you just predict on that missing value and then use that to fill it? I never thought of that. I don't know if you guys have ever thought of that. But yeah. If that
meaning that you predict the missing value and use that?
Yeah, exactly. Instead of doing a mean or a median or any of that stuff, you like use a random forest using everything else to predict that missing value and then pop that in there and then use it like as that is your value rather than the mean. Never thought of that, but yeah, it seems pretty obvious after I read that. Don't know how much of a difference it makes. Or if it's just being too particular about things.
But it is exactly to your point. It's an idea that we can carry in the pocket to apply in many other places where that might be relevant. Like
exactly.
And predict and then use the prediction, right?
Yeah. And their claim is that
idea is
on average it does better than just using a median average and something else they had tried out in their experiments. But again, this whole world is so finicky. And nothing is so generalizable.
You know, YMMV as they say.
The moment you say you're using a seed as a hyperparameter, everything just goes down. So yeah.
One question was, can we do like, there's this NVIDIA library called Rapids. So can we do pip install Rapids in the notebook if it's like, or if it's internet not allowed, that pip install is not allowed?
You can't pip install, but yeah, in the last competition, the Ubiquant competition, they used Rapids, and so there is a data set. So because there's a data set, you can pip install from the data set
Oh,
if your
okay.
internet's off.
Yeah.
So yeah, again, if you look at like that competition and just search in the code for Rapids, there was a couple of notebooks used it.
Okay. And okay, that's the link you put, right? The previous Ubiquint. Okay, Uquant.
Yeah,
Yeah.
Terrence put it. Yeah.
Okay. Thanks. Yeah. Cool. Yeah, I heard a lot of good things about this Rapids.
Yeah.
Yeah.
I came across another library called Polars in this competition currently, which is for like huge data frames. And I don't know, did you guys, I forgot which notebook it was, but I was just reading one of the notebooks and I came across Polars, and they say that you don't have to read everything in,
I heard
keep
about
stuff in
it.
memory. Yeah. But your Rapid, since it's NVIDIA, I'm guessing it's better.
Yeah, I know. What do you call the guy from the last competition? Chris Diop.
Chris Diop, yeah.
Yeah, he works for NVIDIA,
Yeah.
doesn't he? So he's always using Rapids in his stuff.
Rapids, yeah.
Yeah.
Yeah. I think he's trying to plug it.
Yeah, I think NVIDIA is funny, right? Like they're making, because so I work in the startup, right? And we are a small partner to NVIDIA, and it's really weird. Like they're making like billions of like their hardware, and now they like, I don't know what they're doing with Rapids, right? Like they're trying to sell it, and now with us, they're like, we are medical imaging, so they're trying to sell like a medical imaging enterprise container. Yeah, I'm like,
okay.
dude, you already are making. Yeah, so it's just like, do you need more money? Just give it for free. Yeah, but Chris, they hired everybody, right? They hired Bohan, they hired Chris.
Yeah.
Two more guys, I don't remember, but all the Kaggle.
Yeah, no, even this guy, the guy who published a lot of basic train data on our LLM competition. I forget the name of the guy now suddenly. Published, he does or did a lot of work. In fact, got into NVIDIA through what he did with Fast AI.
Oh, wow. Okay.
Get the name of the guy now.
Oh, Radek.
That guy.
Radek.
Yeah. Radek is also at NVIDIA, and
right.
He does periodically publishes. In fact,
he's on the recommendations team, so he has a bunch of interesting recommendation articles. Merlin, NVIDIA's other product, yeah.
And then I think in one of the Python conferences or something, the guy who is the lead developer for Rapid was actually presenting on Python, and how to optimize performance in Python or something. Because Rapids is essentially, if I recall correctly, accelerating pandas, right?
Yep.
To run faster. And Polar is similar to Nickel, or?
Not 100% sure, but I think Polar's other capability was not reading the whole thing into memory. I'm not 100% sure whether if it takes care of that.
Oh, I see.
So I don't know if it is more on a streaming basis that it's more helpful, or there's so much stuff out. I don't know which road to follow. So
yeah,
nice.
And there's all this Ray stuff from Berkeley, right? Which does this multi-GPU.
Yeah.
Stuff on not training on a single GPU, but distributed training and stuff like that.
Right. So it's nice like this when someone in the group shines a light, and then you can follow them to kind of get to some place. So yeah.
But anyway. Okay, thanks for the combinatorial Perch CV link to, and post all these links. They're done.
Yeah, you'll probably remember it when you look at it. It was definitely something we looked at before. It's the sort of the famous
Yeah,
way for
no, I
cross-validating that.
you know, I wanted to spend some time on just this time series split because I haven't seen anybody use it, and I was like, man, what do you even trust? That's the one thing I remember. I don't remember a lot.
It sounds like from what Steve is saying, he's not using time series split, but he's inherently doing time series split, right? He's just not using time series split because he's splitting it by time, so it's chunking it, and he's not never looking at anything in future. So
Yeah.
So it's like Steve has written time series split.
Yeah, Steve is doing that, but none of the other notebooks that I saw are, well, actually, now that you mention it, maybe that's the reason, because if you have the time ID and you ensure that
You split based on
that your split is based on that,
should take care
then
of.
you can guarantee. But then I don't know how you can get. Well, I guess you still could get it, just that your data sizes will be different, right?
Yeah, exactly.
There's no way to split it with equal data size if you're splitting it based on time and not using future time.
I don't know, like for example, if you think
have
just writing code like that, it's just writing two if conditions, right? If greater than the state, less than that date. And if you have those many number of rows, you just chunk by those rows, you can do that. But I don't think even time series splits wants to do that. It's like you progressively want to add more data. So it's like 100 rows, then you go 200 rows, and then 300 rows, rather than doing like 100 rows, 100 rows, 100 rows, 100 rows moving in future. So, yeah. Yeah. I'll share some stuff from the book that I'm reading on the side with you guys, which I find interesting and relevant to the competition. So maybe we could plug and play and see about,
that'd be good.
Yeah, like feature importance and those kind of things. Or if there's anything interesting. Yeah.
I'll try and see whether I can get hold of that book.
Oh, yeah. Like 30, 35 bucks.
You said chapters 5 and 6?
Yeah, chapter 5 and 6 are the ones which I think are the best.
Okay. Okay. Sounds good.
Yep.
Thanks, everybody.
Okay.
See you all next week.
Take care.
See you later.
Nice. See you guys. Bye.